Most people don't put it in scientific notation, but if you put it in scientific notation and put like 60.06 times 10 to the first, I would take that. My brain works back and forth between scientific notation without difficulty, so it would be fine. Okay? All right, and the last one was the one y'all said, yeah, we did number 5. It was number 3 in the 5 assumptions. What's an elastic collision? It's number 3 in your 5 assumptions. No net loss of kinetic energy. Okay, it was the one that we talked about, was the new vocabulary word yesterday. All right, I don't remember which class I talked about it, and I compared it to underwear and leggings. Okay, I must have done third period. What? I said something about what, Justice?
Somebody read it.
Okay. All right. I compared it to elastic and leggings and underwear somewhere. Okay, I used pool balls.
And Jaden and Tiffany.
And Jaden and Tiffany. Okay, that was in here. All right, questions about that? All right, let's talk homework real quick and see if you had any issues with converting. Because again, all of the conversions that we'll do in these word problems are a standard deduction. So you need to be able to make these and be able to do them pretty easily. Because I don't want you to lose points for converting wrong. All right, question number 1. You should have an answer. Everybody got it out? I don't want you to say, what, go back. Say what? Yes, that one we're going to do tonight for homework, so hang on to it. I don't know which numbers exactly. I can tell you which ones I'll choose from if you want before you leave. But typically I only give one or the other of the 2 questions for Boyle's Law. I mean, hand it to me and I'll tell you which ones I'll choose from. Okay, or you can watch the video. Okay. All right, so number 1, 311K. Number 2, negative 148 Celsius. 3, 1.25 liters. 4, 0.04175 liters. Or if you put it in scientific notation, 4.175 times 10 to the negative second liters. I'll do it in a second. 5.169 moles. 6, 15.2 grams. 7, 6.33 times 10 to the 4th PA. 8, 935 torr. 9, 389 kPa. And 10, 1.69 times 10 to the 4th PA. Yep. All right. Number 6 says, all right, 0.475 moles. And we're going to grams. All right. What goes beside moles? 1. And we're going to grams. What do we know about oxygen? It's diatomic. Okay. So oxygen's formula is O2. So when we calculate its mass, it's 2 times whatever its mass is. What's the mass of oxygen? 16. So 2 times 16 is 32. All right. That's number 6.
What did you say number 7 was? 6 point what?
33 times 10 to the 4th. So 63,000 something.
Can you do number 4?
All right. Number 4 is 41.75 centimeters cubed. You're changing it to liters. What do you know about centimeters cubed?
Same thing as milliliters.
Same thing as milliliters. All right. That's the same thing. So 41.75 milliliters. Changing it to liters. Who's bigger, a liter or milliliter? Put a 1 there. This is the one I told you yesterday. You might want to memorize, but if you don't, it's okay. King Henry died by drinking chocolate milk, because you're going to see lots of milliliters. Liter is on the baseline. 1, 2, 3 spaces. So 3 zeros. You probably did centi, because centi to liters, a lot of people use 2 zeros. Okay, remember, milli and centi are the same thing. Centimeters cubed and milli are one and the same. So that'd be 1,000. So you're going to get 0.0 4.175 when you divide, and liters.
Yeah, I got that.
That's-
Unless there's something else when you're going to.
I called that out, and then I said 4.175 times 10 to the negative second. I called out both answers.
Yeah.
What was
I only
five?
heard the 4, please. That's what I was like, what?
What was five?
5 was
5 was point.
0.169. You probably forgot that nitrogen's diatomic if you didn't get it.
Oh,
You
can
forgot.
do number 2 too? Because I forgot how to do that. You do number 8.
Yep. So K equals C plus 273. So you've got 125K. So K equals C plus 273. So subtract 273 on both sides. This will cancel. So 125, subtract 273. All right. So 8, 1.23 atmospheres to torr. All right. Atmospheres to torr. All right. Atmospheres to torr. What goes beside atmospheres? 1. Torr gets a what? 760. Right? No, that one was 8 for Tiffany.
I got the from.
I guess if you need to. Yeah, you just write your name down. Take the vest. Make sure you throw your trash away. Stay here, that means you have none left.
Nope.
All right, you need, what'd you say, which one?
7.
7. All right, 7 is what, 475? MMHG to PA. Okay, so MMHG on the bottom to PA. So MMHG gets what? And PA gets 1.01325 times 10 to the 5th. Okay. Now, when you do that, you're going to get something like 63,000. But I changed mine to scientific notation.
I have that.
Okay. 63,328. So
Yeah. I did the chart.
I have a question.
Did you do the regard?
I mean, did you punch it in the calculator wrong?
Probably.
Okay. I mean, you have the same numbers. So punch it in and see if that fixes it for you. All right. Did you do, which one, Tiffany, did you say 9? You just punching it in wrong? I mean, you got the ones with ATMs here. 3.84 atmospheres. Atmospheres is on the bottom. KPA has 101.325. Atmospheres has a 1. So you're just multiplying. I mean, it just strikes me as odd that you're doing that wrong.
The significant digits now.
As long as you're within 1 or 2, I am not going to get bent out of shape. Okay? Now, if you write down every number on your calculator, yes, I'm going to take off for significant digits. But if you're within 1 or 2, no. All right? Anybody else question on the homework? Have I solved or gone over most of your mistakes?
You got one.
I just about did do about all of them on the paper. You are correct. Anybody else have a question? Yes? No? All right. Let's talk gas laws. Now, we've got to talk about the theory behind them, and we've got to talk about the formulas and how to work them. The nice thing about all 4 gas laws that we're going to do today, or hopefully do today, is they all work the exact same way. Okay? So, those of you who are not the strongest math students, the nice thing about the gas laws is once you master how to solve one, the rest of them work the same way. Those of you who are really strong math students, you're likely to be bored. Because once you figure out how to solve one, they all work the same way. Okay? You're going to add to them all. Which is why on Monday's quiz, we should do well. Because they all generally work the same way. Out of the 5 gas laws, 4 work one way, 1 is different. Well, you know. Now, out of the gas laws, I've separated them into 2 categories. We're doing all the ones that do not have mass and moles first. Okay? So everything we're going to do today, and really the first half to a little more than half of the day tomorrow are not going to have mass or moles. Okay? So when I gave Samaria and Xavier, who are not going to be with us tomorrow, the review sheet, everything on the review sheet tomorrow has no mass and no moles. Once we've practiced all of that stuff that will be on Monday's quiz without moles, and we've got that under our belt, then we'll talk about bringing in mass and moles. Once we bring in mass and moles, remember all that stuff we used to do with grams and balanced equations and stoichiometry?
Do we get to do that again?
Yes, we do.
Yeah.
Okay, so we're going to do the gas laws first, and then we're going to bring in all that old stuff that y'all hated. So easy stuff first, then we'll bring in the harder stuff. Okay. Some people really hated it. So, to give you a little background, Boyle's Law, just so you got a little bit of a headline, because all of these are going to have variables. Boyle's Law is pressure and volume at constant temperature. Okay? Boyle's Law is pressure and volume at constant temperature. So, we have to know how the gas laws work. Okay? Part of the stuff on the test is understanding what happens. So, how do the gas laws function and operate? Let's say that we have a container. Some gas is in a container. The number of particles, okay, the number of moles are also constant. So I'll put that over there with the constant because that's not really important for us and what we're talking about. So when I draw in some gases in here and some little dots, do you need to concern yourself with how many I'm drawing? No, I'm just drawing in some dots. How many is irrelevant? So, and y'all know that I can't draw, so my thermometers tend to look like ugly pickles here. We're just going to make the temperature 50 degrees Celsius for the purposes of our conversation here. Yeah, it is kind of ugly, but I can't fix it. So, we're going to do what? Let's say that our volume is 1 liter. And we're going to shrink it to half a liter. Okay. And now my thermometer looks like I'm in a billy club. All right. Now, we have to understand what's happening inside of my container. colorful when they respond this morning.
It's amazing. I just made a second. Funny that one.
All right. Has everybody had a chance to copy the diagram down? All right, so if we look at the picture that's up here on the board, okay? If you look at that, when you look at what's right there, tell me what creates the pressure inside the container so that we can analyze what's going on. Okay, what do the molecules do to create the pressure? They have to move, yes, and what do they have to do to create the pressure when they move? What creates the pressure inside the container? Not the temperature. They have to do what?
Get close together.
Well, they get close together, they vibrate, they do what else?
Exchange.
If you have an aerosol can and you put it in a flame or heat, what creates the pressure?
The heat.
When it does what?
Yep.
What do the particles do inside the can?
They expand
Okay, why?
due to the temperature.
What does the temperature cause the particles to do when they expand? Yeah, y'all are missing the boat here.
Really fast.
Explode.
Really fast.
Move fast.
Okay, yes. And when these particles in here move faster, what do?
Hit each other.
They hit each other and what else? There you go. All right. Pressure is created. Let me move the is a little further away here. All right. Pressure is created when the particles hit the walls of the container and each other. Okay? That's how pressure is created. All day long. When I ask about pressure, that's how pressure is created. So any of you who've ever heated an aerosol can, or anything else for that matter, and you should never do that, by the way. Any of you who've ever put a flame in front of an aerosol can trying to be cute, you let up on the aerosol can and the flame gets sucked back inside, it can explode. Be very careful if you ever do that. Now, pressure is created when these particles hit the side of the container and each other. Okay? Now, if I cut the volume in half, what's going to happen to my numbers of collisions? Are they going up or are they going down? They're going up. Okay? If volume decreases, there is less space for the particles to move. There are more collisions, which means there is greater pressure. So, what happened? Volume did what? Okay, so volume decreased. Pressure did what? Pressure increased. So, what's the relationship?
Inversely proportional.
Okay. That means that it's inversely proportional. Now, we'll write the law on the next slide once you catch up, and I'll show you the formula that goes with it.
Proportional. That's good.
All right, has everybody had a chance to catch up? Still, anybody still writing?
No.
All right, so Boyle's law says pressure and volume are inversely proportional at constant temperature. Now I'm going to write and moles here in parentheses because I don't want anybody to think moles is changing. All right. Now, the formula that goes with this is P1 V1 equals P2 V2. Now, notice what's not in the formula. Temperature is not in the formula because what do we know about temperature? It's what? It's constant. So it's not going to be in the formula because constant means it's not what? It's not changing, so it's never going to be in the formula because it's not included. All right, has everybody got it now? Okay, now here's our sample problem. And I would only write one for each of these. I would not write more than one because the sample and the practice are all going to work the same way.
Is this the shortest one or the longest?
Hold on. I'll let y'all pick. There's one, there's two.
Done. Correct. Number one.
Okay. caught up, waiting, or Matt?
Oh, right.
Still writing, okay.
Oh, yeah.
All right, have we finished writing so I can walk through it real quick? Like I said, those of you who have strong math skills, a lot of you could probably work this without me. Now, for those of you who can't, when you look at this, the nice thing about these problems is they all work the same way. First of all, you need to make sure you can identify the units and put them with the correct letters or symbols. When you look at 150 milliliters, what's a milliliter? A volume, a temperature, or a pressure? It's a volume, okay? Now, when you read the question and it says 150 milliliters when its pressure is 720 millimeters of mercury, what's a millimeters of mercury? Is a what? It's a pressure. All right, so this is a volume and that's the pressure. Those two things say when its pressure is. See how that shows possession in English class? This volume and this pressure have to stay together. They're a couple or a pair. It doesn't matter if you make them V1 and P1 or if you make them V2 and P2 as long as they're together. You with me, Marissa? You have zoned out. Come back or Jaden's going to be yelling at you that you're not listening. Okay? They just have to stay together because they're a couple or a pair. Okay? It doesn't matter which side they're on as long as they stay together. You see the way it reads? When 150 is with 720. Now, because they're first in the problem, where do I tend to put them? I make them the V1 and the P1. So 150 milliliters is a volume and 720 mmHg is a pressure. So I just make them V1 and P1. Okay? What volume I make V2 when its pressure is 750 mmHg. Now, the only other thing we have to do before we solve is these units right here. These units must match. Okay? That's it. Those units have to match. As long as they match, you can solve. If they don't match, you have to make them match. Does it matter what units they match to? Absolutely not. Okay? Let's just say this one was an atmosphere and that one was an mmHg. You can make them both atmospheres. You can make them both mmHgs. Let's just say Tomas like kPa. You can make them both kPas. Okay? It doesn't matter. It doesn't even matter that neither of them have kPa in the question. You can make them both kPas. They just have to be the same. Does that make sense? Now all you got to do is plug and chug. At this point, the chemistry is completely over. You are left with math 1. Okay? The formula is V1 P1 equals V2 P2. And I have no idea what I wrote on that last board. I might have written P1 V1 equals P2 V2. I have no idea. It doesn't matter. I switch those variables back and forth constantly, and I apologize because I can never remember what order I wrote it the last time. Okay? So V1 is 150. P1 is 720. V2, I don't know. And P2 is 750. I'm not going to pick up a calculator until I'm done. Okay? How do I solve for V2? Divide by what? What did you say?
Oh, yeah, time to.
No, but no times until I'm done. How do I solve for P2?
Divided by
Or sorry, how do I solve for V2? I forgot what I solved for. Divide by 750. You will not see me pick up a calculator until I have solved for my variable. Okay? Even when we have 5 different numbers floating around on this board, you will not see me pick up a calculator. All right, so what do we get? Because I know somebody's done it. 144, thank you. Now, for our unit, remember, the units had to do what?
Match.
So, when I look back here at my V1, what was my unit?
Milliliter.
So that's what tells me my unit for my V2, because they have to match. Does that make sense?
Mhm.
Yes? Jonathan, have you died? Are you okay? All right. Can you solve now? Can you do it on your own?
Yeah.
Fabulous.
Ain't that what Don right back?
No. If you've got one, the next one works the same way. I would not write but one. Okay? All right, y'all solve. Let's find the answer. Find me the answer. Find me an answer.
I don't feel like I'm back on
All right, we got an answer?
Yep.
All right, what we got?
1,000.
All right, so when you look up here, a couple of you looked at that altitude stuff and you were like, what's that got to do with anything? Is it important?
No.
No. Sometimes on the exam or even in other questions like this, or I might just put it on the test to throw you off. You don't need it. Nobody needs to know anything about an altitude. That's just junk. All right, so when you read the question, this is a what?
Volume,
This is a what?
pressure,
Okay, so volume is what?
500.
And then it says at a pressure of 1. So that has to stay with it. What are they asking you to find?
Volume,
What volume? When the pressure is what? Okay. So V1, P1 equals V2, P2. So V1 is
500 times 1 equals V2 times 0.5.
divided by.
0.5.
So when we do that, we get 1,000. Is everybody okay with that? Anybody not okay? Yes, no?
Fine.
We're fine. I know Samaria's fine. She's pushy about it. Is everybody else okay?
Yeah.
All right, let's talk Charles.
Are you okay? Huh?
Well, Marissa's just zoned out. She'll ask me in 5 minutes what we said 10 minutes ago. Just kidding. Marissa's with us today. All right, let's talk Charles' law. All right, Charles' law is volume and temperature at constant pressure.
So this is with constant pressure, not temperature.
Okay, volume and temperature at constant pressure. Okay.
Would
So-
the, moles still be constant?
Yes. All right. So if I write that under here, that's still moles is constant
So the
also.
roles never change.
Moles are not going to change for us until very late in class tomorrow at the earliest. Okay. So all day today, moles are going to be constant. We're not going to change those. Huh? Number of moles. Okay. Our moles are not going to change. Not today. We're going to do 4 laws. We're going to do this one. We're going to do Gay-Lussac and the combined gas law today. It's just the man's last name. I do not know anything about him. All right.
Time for more pickles.
Yep.
Let's have a look at this. You know what?
She said, I don't even know what she said.
I love me a peanut butter and pickle sandwich.
Oh, very good.
Then the rest of it, I'm working an egg with it.
Peanut butter and pickles is
Why you like peanut butter and pickles?
Don't you make that face.
Are you being serious?
I'm so serious.
Yeah, Jada made all of us try it.
I made all of my friends try peanut butter pickles. All of them. They didn't find it nasty. I promise it's so
No, I don't like it.
All right. Maybe I'd have to try it then because
You do need to try it. Go home and try it today.
Oh,
It's gonna be great.
I'm gonna do that.
But your pickles can't have all the juice on it because it's gonna be nasty. It's gonna
what do
make
you got to do? Dry the pickles?
yes.
You gotta drop it.
That's why you don't be having
You can get a jar of pickles and they got a juice in it.
strain them a little bit.
All right.
Yeah.
My son who doesn't like any food is going to watch me make a peanut butter and pickle sandwich.
And then he
I'm
has to
really
like
picky,
people
but
with it.
that's one thing I do enjoy. 75.
You do.
75.
It's almost as bizarre to me as a banana and mayonnaise sandwich.
I don't eat steak.
I don't eat steak. I don't eat cow. I don't eat
Baked
bacon
chicken,
chicken, grilled
bananas,
chicken,
and mayonnaise.
My mother-in-law.
I don't like grilled chicken.
Same person that eats pickles and
I
peanut
only
butter.
like fried chicken. That's it. That's the only chicken I eat.
I really like fried.
Or chicken nuggets.
Chicken nugget.
Processed chicken. I didn't eat it.
No, I just think it's like fried chicken.
Y'all should have been around when McDonald's chicken nuggets first came out. It used to be like dark ones and light ones, and then they had little grizzly pieces running through them.
That's why
Well, they used to have
Like
those
gristle
fatty
stuff,
pieces.
yeah.
Yeah, because
And
they
I
didn't
thought, why not
use
one?
all, like meat chicken. It was, like all parts of the chicken. They just ran it through the blender and made little chicken nugget patty kind of things. So when you got the chicken nuggets, it was like, you break it open and see what was in the chicken nugget. It was like, ugh, throw that one out and break over the next one and be like, okay, that one's safe to eat.
Well, now their chicken is made by Tyson, right?
Yeah, it's much better quality than it used to be.
Because they still talk about how their chicken nuggets are chicken paste.
Well, you kind of is.
Where?
You should have seen it before.
Well,
But I
it
mean,
is
Tyson makes their chicken nuggets now, and they use all white meat.
because it has to be formed into the chicken.
Well, I know, but you should have seen it before. I mean, it was borderline, you got the beak in the chicken patty. All right, so, just saying. So,
It's nasty. Okay.
you never knew, you might get a toenail. So, if you got Charles' law, what creates, talking about volume and temperature this time, right?
Yeah.
Pressure is constant. So, the particles are doing what inside the container? They're moving. They're hitting the container walls, right? So, what am I doing to temperature this time? Temperature's going up. Okay, so temperature increases. So if temperature increases, do collisions occur more often or less often?
More off.
More often.
Okay, collisions occur more often. All right, so if collisions occur more often, what's going to happen to pressure? Pressure's going to go up. Okay, pressure will increase. Okay, we want pressure to remain the same. How can we alter volume so pressure stays the same? Okay, so as you're writing, I want you to think about it. So you're heating it, right? Particles are moving faster. They're going to bump in the container walls more often. You don't want the pressure to go up. You want it to stay the same. So how? You don't want the temperature to go down because you raised it. Hold on a minute, I know you know the answer. So the particles are hitting the container walls. You don't want them to raise that pressure. So what can you do to the container so that the pressure does not go up? What can you do to alter the container so the pressure does not go up? You want it to stay the same. There you go. Okay? So all you have to do is increase the size of the container. Okay, so if you look, we did what to temperature?
Increase it.
And we did what to volume?
Increase it.
So we increased temperature, we increased volume. So what's the relationship this time? That's right. This time we're directly proportional. And I'll write the law and the formula on the next board.
Tiffany,
Yes, ma'am.
have you redone your schedule yet?
No.
Well, if she's not gonna pull us in before the end of this year, then I would just say bump it.
She said that if all else fails, she'll do it this summer, but I don't see how she would do it.
I'm for real, if they don't make no efforts, then I'ma just leave it the way it is.
Then I don't wanna hear her next year when we have the classes, cause I'm sure I have to sit here and wait for her to change them, and they won't change. And I went up there and talked to Miss Floyd yesterday, and she said she wasn't gonna change it right now until Miss Burton said she was ready, so I was like, oh, well.
Wait.
There you go. Don't worry about it. Everybody caught up?
Yeah.
Who said no?
My grandparents, my face, my great grandparents. Marissa writes slow.
I messed up my picture.
She writes slow.
That picture can be drawn again later. I already redrew it.
Oh my God.
Okay, you're good.
All right. So, volume and Kelvin, temperature are directly proportional and I got to write the formula at constant pressure. I'm going to write and moles in parentheses again. The formula for this one is V1 over T1 equals V2 over T2.
Oh, yeah. I was teased. I was so teased. That's funny. It'd be like that. Right.
Now, notice I used a particular word in the way I wrote that law. What's the key word we need to talk about?
Kelvin.
Kelvin, okay? When we solve here in this next word problem we're about to write down, I wrote volume and Kelvin temperature are directly proportional. Why do you suppose I wrote Kelvin temperature in that law? Okay, well, why do we have to use Kelvin though? Why can't I just do it in Celsius?
Okay, told us not to.
Okay, why did I say we can't and why did I tell you not to?
That was it.
So that's how it's.
All right. Aside from the fact that I'm Miss Wall and I'm all-knowing and I said we can't, what's the reason scientists said I had to tell you we can't?
Good.
All right, I need you to think about math class. Why would we not want to have a Celsius temperature in the denominator? What would be the reason for not wanting Celsius negative? All right, we can't have a negative because we don't want a negative volume. That's one reason. I need one more.
The numbers get too high.
All right, what about absolute zero?
Oh, is that?
No, you're on the right track though. What about it?
Kelvin is absolutely zero.
Kelvin is absolute zero, yes, but that's not what I'm looking for. What other number could we get on the Celsius scale that we don't want besides a negative number? Zero. Why would zero in the denominator be a problem?
Because that's like zero.
That's right, it's undefined. In math class, you can't have a zero in the denominator. It's an undefined number. Okay? So you can't have a zero down there because we can have 0 Celsius and we can't have a negative number. So if we put it on the Kelvin scale, are we going to have a negative Celsius? No. And are we going to have a negative Kelvin? No. So that takes out those two problems. That's why you have to do it on the Kelvin scale. Okay? No.
How?
Because you're not going to be below absolute zero. Okay?
Oh.
So, if we cruise back to here for just a second, you know how I said the units had to match? Okay? These will always have to match. When we go to next week and we talk about some other formulas, I will tell you certain things. These always have to be in kelvins when we talk about temperatures. Okay? These always have to be in kelvins. Okay? Down the road, I'm going to tell you some units can change. Everybody listening to me? Down the road, I'm going to tell you some units can change for volume, for pressures. The units can change. Are you listening?
Yeah, we listen.
The units for temperature always stay in what?
Kelvin.
Are there exceptions to that?
No exception.
No exceptions. They have to be in what?
Kelvin.
Okay.
Celsius.
Y'all still ignore me. All right, this is the first one. That's not that one. That's the second one.
First
Okay. All right, that's the second one.
Sam, so should I put in another application?
Yeah, the application on the last 30 days.
Now, notice at the end of this that it says if pressure remains constant. What if you have a problem where it just stopped at the 50 degrees Celsius and it doesn't say anything about pressure?
You assume it's constant.
Just assume it's constant. Okay, some problems may not say that it's constant, it just doesn't mention it. If it doesn't mention pressure at all, assume it's constant, because some of them won't. Yes, but dear?
We gotta convert to Kelvin.
Yes, I'm going to do that.
That's not fun. School ain't fun.
What's the lowest temperature that's ever been reached?
I don't know, I'd have to look. It's probably pretty close to absolute zero though.
Hey.
All right, so when you look at this, all right, same rules apply, just like I told you. This one is even easier. What can you tell about these numbers? When you look at this, see how it says 752 at 25?
Yeah.
That means what?
Together.
They're together. So 752 milliliters is a volume, and 25 is a temperature because it says Celsius. All right, if you keep reading, what is the volume? And temperature is 50 degrees Celsius. Now, I think it was Samaria a minute ago who just yelled, do we have to change them to kelvins? What is the answer? Yes. You can't work the question if they're in Celsius. If you work it in Celsius, you will get the wrong answer. Okay? So 25 plus 273 is 298. Now, any of you who are not sure how we did that, the formula we were using is the one we used last night in our homework to convert. So 50 plus 273 is 323. Normally I do that in my head, but I don't think my brain's functioning fully yet. Okay? So now all we have to do is, like I've said before, it's the plug and chug version of the formula. This is all math 1. None of this is really your chemistry skill. This is falling back on your math skill. So your V1 is your 752 over your T1, which is 298, equals V2 over 323. Now, I don't care how you solve it. I only solve it one way in class. If you have great math skills, you can solve it any way you want. Now, given I only solve it one way, the way I solve it is always to cross multiply. It's the way over the years I have found more people are successful than any others. If you multiply by an inverse, reciprocal, however you learn to do it, fabulous. Keep doing it that way as long as you get it right every time. If you don't get it right every time, you need to reevaluate the way you're solving. Okay? 752 times 323 equals 298 times V2. Again, I will not pick up a calculator until I have the variable by itself. So don't tell me what anything equals. I don't care. Divide 298. Divide by 298. Now, when I look at your paper, if you've done this, do I have any question about what you're multiplying and dividing to get your final answer? No. If you have a bunch of strange numbers written on your quiz paper, do I know how you're getting your answer? Am I picking up my calculator to figure it out? No. Okay? Depending on how much work you have written down, if your answer is wrong, you lose points. I got 815. Did y'all? Okay, so 815 milliliters. All right. Now, let's say for a minute that, you can put a decimal if you want. I don't care. Remember, I'm not grading significant digits. Now, let's say that the question wanted the temperature to be found is our variable. And they said, what's the temperature in Celsius? Could you solve for the question in Celsius because it said, what is the temperature in Celsius? No. You'd have to change the temperature to what? Kelvins. Solve it in kelvins. And then change your answer back to what? Celsius. Okay. Just making sure we're all on the same page with that. Now, write this down. You're going to see this in word problems. Okay? And I stuck this here because I have a bad habit of not talking about what this is. And it pops up and y'all are like, what's that in this wall? So I just threw it in the middle of the slides because it'll probably pop up in your homework. All right, STP means standard temperature and pressure. It's an abbreviation. All right, we use it all the time. You're going to see it lots all this week and next week. STP means standard temperature and pressure. It's shorthand. Now, sometimes we'll use both and say STP meaning both of them for standard temperature and pressure. It's on your blue charts. For those of you who've never looked at your blue charts, on the front page. Now might be a great time to get your blue sheets out, by the way. If you haven't looked at the front page of your blue charts, just to see what it has for the gas laws, because it has a lot of stuff for the gas laws on the front page. All right? Standard temperature is 273 Kelvin. Okay? It's on the front page. Standard pressure is 1 atmosphere. Sometimes the question might just say, at standard temperature. If it just says at standard temperature, you're just going to use what number?
273.
You're just going to use that 273. If it says at standard pressure, we're just going to use what number? Then 1 atmosphere. If it says STP, you're going to use how many numbers?
2.
You're going to use both numbers. Now, a lot of times when people read STP, they assume we have how many numbers, Talia?
3.
You with me over there? No, you're not. You're zoomed out, staring out the door. Come back in here. All right? If we read STP, I'm giving you how many numbers?
2.
I'm giving you 2 numbers. Okay? I'm telling you, you have a temperature of 273, and you have a number of 1 atmosphere. You have 2 numbers. I don't have to physically write 2 numbers in the question. Okay? If you forget those numbers, you can find them where? On the front of your blue sheet. Don't come to me on the test to come as well. Where are those numbers at? Because I won't tell you where they're at. Okay?
Okay, so the blue sheet has 4 different numbers.
I know.
Like, in the question, is it gonna like specify which one we have to use?
Nope.
No.
Will it come out to the same answer?
Yep. If you know which one to use.
Oh.
All right. So here's your sample. Find me the answer.
You want to write it?
Nope. You already got a sample.
Oh, shoot.
Find me the answer. Then we're going to talk about Gay-Lussac, and we're going to do the combined.
A little bit.
Oh, yeah.
Right.
I thought it would. Yeah, but I didn't say that.
Oh.
Do you have to put it in scientific notation?
Come on, you got it done? Doesn't sound like it. Yeah, right.
Did you say put in scientific notation? Or does it matter?
I said it doesn't matter.
Hey. Hey, Jesse.
All right, we done?
Yeah.
All right, so if we look at what you got. All right. Did you have the V1 was 2.75 liters and the T1 was 20 and we changed that to 293K? Okay. And then V2 was 2.46 liters and we're solving for T2. Everybody okay so far? Okay.
Yeah.
So to solve for V1 is 2.75 over 293 equals 2.46 over T2. So I'm going to do what to solve? Cross multiply. So I have 2.75 times T2 equals 293 times 2.46. So to get T2 by itself, I'm going to do what? Divide by 2.75. Divide by 2.75. Get out of my way. T2 equals.
262.
So 293 times 2.46 divide 2.75. I got 262. All right, now what unit is T2 in? That's in what? So that's in Kelvin. Now, does the question say to find my temperature in Kelvin or Celsius?
No.
It doesn't say, right? So if it was me, I'm a little on the lazy side. It just says, what is the outside temperature? I would leave it in what? I'd leave it in Kelvin. Because if it doesn't tell me to find it in Celsius, I would just leave it in Kelvin. Say what?
If you change it back to Celsius.
It's fine if you changed it back, but unless it asked me to change it back, Justice, I wouldn't change it back. Okay, I'd leave it in Kelvins every time unless they told me to change it. Okay, just because I'm lazy. And most of the time, they're not going to change it back unless they ask. Okay, what'd you say?
So it's always going to be Calvin.
Yep. Okay, everybody okay with that one? All right, let's do Gay-Lussac. Gay-Lussac is the easiest one to understand the explanation for because it's the one y'all are the most familiar with. Okay? Yeah. All right, so Gay-Lussac is pressure and temperature at constant volume and moles. All right, this is the one that you guys would think of with like aerosol. I don't know if I spelled that wrong. I think there's a vowel missing. A-E-R. How do you spell aerosol? There's a vowel missing.
Use the I.
There's not an I in aerosol. I think there's an E. There's an O.
Oh, no, I can't spell.
There's another vowel missing somewhere in there. But anyways, aerosol cans, all right, when y'all heat those, and the warning on the back that says don't exceed a certain temperature, I don't remember if it's around 50 degrees Celsius, 52 degrees Celsius, something like that on the back. The reason for that is Gay-Lussac's law, okay? But aerosol cans fall under this. So you guys know if you have some gas molecules inside of an aerosol can, right? And what happens if you heat it up? If temperature is increased, what happens inside? Don't tell me boom, that does not explain jack.
It explodes. It expands.
I need something more. Tell me about the particles. What do the particles do?
Move faster.
They move faster. And if they move faster, they do what? All right, they move faster, collide more often. All right, so if they collide more often, what's going to increase? That's right, pressure will increase. All right, then, all right. All right, then it can explode. All right, so what did I do to pressure and temperature here?
The increase. And you got an Apple Watch.
Yes.
She got a MacBook, the latest iPhone, and Apple Watch.
Miss English got a MacBook and then a little bitty slide phone.
Yeah,
That's not really important.
Right.
She got them little slide phones I had in third grade where it goes zoop.
All right, so if temperature is increased, pressure is increased, what can y'all tell me?
Directly proportional.
That's right. All right, pressure increased, temperature increased. And they're directly proportional. All right, you got it?
No.
Yeah.
Anybody I'm waiting on? All right. Now, this one is not a short one, but the writing's just large, I think. All right, that one's the shortest one.
Oh my God.
What? I gave you the short one.
Too much.
That just shows you the other one even more long.
This one got it right there.
Who is screaming?
You're screaming, I hear Ms. Rector's video or something.
Wait, is the formula the same as the last one?
Is which one?
The formula for this.
Yes. Oh, I didn't, hold on.
Yeah,
Crap, I forgot to say the formula.
I knew I wasn't.
Oh, sorry. No wonder y'all are looking at me like I'm crazy. All right, so the pressure and temperature, we already, Kelvin temperature, are directly proportional. So that's good, right? So the formula would be P1 over T1 equals P2 over T2. Does that help?
Yep.
Sorry, I completely spaced that.
Okay, we good.
Can I go back or do I need to wait a little longer?
Okay.
All right.
Ow.
Hey.
I figured given we've done 4 of these, everybody would be okay on this, but maybe not.
This is our third formula, right?
Yes.
Okay.
Every time I see ATM,
Which one? Oh, yeah, that's P. Wait, for this one? This one? over YouTube.
No, he wasn't on the TV.
What? I read it wrong.
Yeah, you're dumb.
Oh, what? That's what?
ATM, like, at the moment, or like,
ATM at the moment, all the money.
Whoa.
Oh my God.
That's your favorite phrase, Maria. It ain't even a phrase, it's a sound. She do that all. She do it all the time. She be like, boom.
So, will we not have to convert it to K since it's asking for Celsius?
Nope, gotta still change it, then change it back.
She just be, oh my God. Oh my God. Warren, you were there.
I know. That's a
That's your catchphrase.
That's what we all the time. Come on, you character. I don't even be doing nothing.
But Karen, she just like, wow.
Karen's my opposite.
Karen be like, what? Then she be like, come on.
Yeah.
What's Shaden's catchphrase?
Nothing. She
I was like, she say a
it.
lot of stuff. I know, I do. I be saying
That is
so
her
many
catchphrase. It's not real.
Yeah.
Then Marissa's is what?
She be like, what?
What are you talking about? It'd be so long.
And it'd be so clear what you be talking. What are you talking about?
What? Huh?
Her catchphrase is confusion.
Confusion. No, I didn't buy me some eyelashes.
For what?
Because why not?
Alright, we got it?
You
Oh,
already said you
okay.
wasn't gonna wear eyelashes on prom because they're gonna get your glasses, so why do you need them now?
They did it though.
Never. Did you wear your glasses?
Yeah. It was with me the whole day.
I know, but I just don't remember.
Can you see without your glasses?
No.
Oh,
I'm
you
completely and utterly blind.
You have contacts.
You should wear your glasses.
You have mama's like Maria should get
Like, I can't, everything's just a blur. I can't make out shapes, colors, faces.
Does she have? I think she does.
No, I don't.
I thought you did. You didn't wear them.
Miss Wall,
Yes.
Miss Howie's on her way.
Okay, thank you, ma'am.
You're welcome.
Somebody to babysit y'all. I've got a sick child.
Yeah.
Alright, so if we look at what you have here,
We need a babysitter.
well, I can't very well leave y'all unattended.
You sick too, you need to go.
I'm not going anywhere. I'm just going to fetch one and I'm coming back. So when you look at this, what do we have? What's this?
That pressure,
Yep. What's this?
temperature,
Alright,
pressure.
this is pressure. Alright, and what's this? Whoops, that was pressure. Sorry, that's what I meant right there. And we're finding the what?
Celsius.
Okay, now, if you heard what Sophie asked, can we leave it in Celsius to solve? No. So we got to change everything, right? So P1 is what? 1.8 atmospheres. All right, T1 is 20. And then P2 is, and then we're solving for T2, which is what we are looking for. So we got to change our temperature, which is 20. Okay, so 293. Okay. All right, so plugging in and solving. P1 over T1 equals P2 over T2. So P1 is 1.8. I don't want the units. All right, over 293 equals 1.9 over T2. So cross multiply, right?
Yeah.
So 1.8 times T2 equals 1.9 times 293. Okay, so how am I going to solve for T2? Divide by 1.8. Divide by 1.8. Okay, so T2 equals 1.9 times 293 divided by 1.8. So 309 and K. Okay, now it wants the unit to be in what? So now we're going to take our formula. K equals C plus 273. We're going to put 309 where? Equals C plus 273. So 309, 273, we're going to do what? So subtract there, except it doesn't look like I'm subtracting. So what do we get? 36. So C equals 36 degrees Celsius. And that will be our new temperature. Questions about how to do that? Does that make sense? Everybody good? All right. The last law, all right, is the combined gas law. Now, all this is a combination of oils, Charles, and Gay-Lussac. Okay, it's a combination of Boyle's, Charles, and Gay-Lussac's law. The only constant is what? Yep. Now, this formula is on the reference table. Okay, this formula is actually on the reference table. It's the only formula that's on the reference table that we've done today. Okay, none of the other formulas are on the reference table. Hey, Miss Howie. I'm good. Well, relatively speaking, anyways. I assume you're only going to be here till the end of the second period. Oh, 12. Okay. All week. Tell you what, they're going to get going until I get back. I don't know if I'll make it back before you leave at 12, because I got to go all the way up to West Davidson back. All right. All right. Everybody got it?
Yeah.
Couple people are still right. Now, same rules apply. What can you tell me about these units for pressure and volume? The units have to do what?
Match.
What can you tell me about temperatures?
Match.
They have to. They got to be in what? They got to be in kelvins. These have to match. Now, I want you. Everybody got it? I want you to try to do that one. And I'm going to hand out homework sheet. I'm going to tell you which problems you got to do. And I'm going to tell Miss Howie what I need second period to do.
We are second period.
I'm sorry, third period, wrong class. Two for Jacob and Samari. I'm going to tell you which numbers. Chill. No, I'm not giving you every number on here. Is the circle ones? Are there circle ones on there?
Hey, That's old.
I wanted to know.
2006. This town is like. This one's bad.
Yeah.
I go get something for someone.
Wait, what's?
I go get this for someone.
Tiffany, come here. Go and lock my computer door.
It's right here.
P1. Here comes in. I have recorded